to record. Chalo, this is just first question. So y40 is, when do you put here? What will you get? You will get 2 square minus m square y20, and y20 is 0. So this is 0. Now y50 is 3 square minus m square y30. So that is 3 square minus m square into m into 1 square minus m square. Is it understood? We can write it in more systematic way. Is this fine? Please respond.
Which derivative we have to find?
Till which you have to find the sequence. What kind of sequence you are getting. Now I want you to observe it. Now I am writing one more and then I will write the output. When I have to write y60, it is 4 square minus m square y40. And y40 is 0, so it is 0. Now if you observe it, I'm writing the final answer and I want you to understand if you are able to correlate or not. See, now just see what I'm writing. yn0 is m 1 square minus m square, 3 square minus m square, n minus 2 square minus m square when n is odd. Okay? When n is odd, and this is 0 when n is even. Is this fine? And obviously you talk about this when your n is greater than 2. Then we write in this manner. Otherwise it will become negative unnecessary. Okay? Is this fine or not?
Yes, ma'am.
So when you have to find yn0, you have to follow these steps. That first you will find y, then you will find y1. See, I'm writing the sequence. First you will find y0, then y10, then y20. Then you will put n is equal to odd in yn0, and then you will put n as even in yn0. In most of the questions, you will get some kind of sequence to connect the dots. Is it all right?
Yes.
Anything you have to ask in it, or should I take the next question? Is it fine? So no question, that means let me finish it. These questions are asked for 8 marks minimum. So you should be very comfortable in solving these questions. And they are not difficult. The only thing that you need to remember is the sequencing. Now I want you to solve the next question. Please solve this question. If y is equal to tan inverse x, prove that this holds and find yn0. I'm leaving first part for you because I'm assuming you know how to solve the first part of it. Can I proceed to the last part?
Yes, ma'am.
Because if I start doing the first part also, then it will take unnecessary time. Okay, now let's see how to go about it. You have y is equal to tan inverse x. Okay, so we are trying to find out y0, y1 and y2. So y0 is tan inverse 0 and that is 0. y10 is d by dx of tan inverse x, which is 1 upon 1 plus x square. So I can write it as 1 plus 0, that is 1. y20 is, you differentiate that again, so minus 2 into 0 upon 1 plus 0 square, and that is 0. Okay, now we have y0, y10 and y20. I need to know what is the connection between y1, y2. Yeah, this is the equation. I hope you have noted down these three values. y0 is 0, y10 is 1 and y20 is 0. Now I need to know the connection between the two. See, this is the connection. This is the connection. So to get y2, you put the value, you got this connection. Now the final equation. The final equation is this. This is the equation that we have to prove. I'm assuming you are able to prove it. Okay. Let's try and find the nth value. So the process is the same. We will put n as odd and we will put n as even one by one alternatively. So first of all, I'll try and get the relation when x is 0. For x is equal to 0, if I mark this as equation 3 becomes yn plus 2 0, because when you put x equals to 0, it is 1 only. This part will disappear, plus n into n plus 1, yn0 equals to 0. Is this part understood or not? Class? Is
Understood, ma'am.
this? Now let's try and find out other value. So I can write yn plus 2 0 equals to minus n into n plus 1 yn0. Okay, just shift it to the right. Now let's put the values. We will start for y3. So the first value that I'll put is n is equal to 1. So I'll get y30 is equal to minus 2 into y10. Okay, and what is our y1? y1 is 1, that is minus 2. Now y40, I'm removing this value so that you can write it one by one. So y40 is minus, see, n is 2, so 2 into 3, so minus 2 into 3, then y20, and y20 is 0, so this is 0. y50 is, we will put n is equal to 3, so when you put n is equal to 3, it is minus 3, you can write it as minus 1 into 2, minus 3 into 4, y30. So what is y3? y3 is minus 2, so this is minus 2 into 3 into 4. Is this okay? No, it will be plus sign. It will be plus sign, no? Because y3 is negative. Are you getting it? What will be y6? I can write y6 as 0 because I know y40 will come and it will be 0. y7. y7, that means n is 5. So just see, minus 5 into 6 into y5. y5 is 2 into 3 into 4. So we can write it as minus of factorial 6. We can write it as factorial 4. This is minus factorial 2. Right? Now if I have to club it, see how clubbing is being done. Till here I hope you all are clear. Hmm?
Yes, ma'am.
Okay. Now just see how you are calculating. When your n is odd, what you are getting? Whatever you have, you are getting just one less than that. And if it is even, you are getting 0. Hmm? No, this is misprint. This is not right. This is not right. If it is 7, you are getting factorial 6. If it is 5, you are getting factorial 4. If it is 3, you are getting factorial 2. So actually the summation is, they are not written. I am writing the summation, just see how we will write it. Yn0 is minus 1 to the power n minus 1 by 2. See, when you are getting, just check, when you are getting 1, n is 1, you are getting minus sign. When you have n is equal to 3, you are not getting minus sign. When you have y7, you are getting minus sign, and so on. So when you summarize it, you will get like this. And then this is 1 less than n. So factorial n minus 1. Okay? When? If n is odd. And this is 0 if n is even. Can we do it in some other way? Like if I put it as n minus 1, will it work? N is 3, sorry, first one is n is 1, then second one is n is 3. So 3 minus n by 2 will be positive. Then n is 5. No, you have to do it this way, there is no other option. Right? And if you find it difficult to summarize, you try to write it in the nth form, that's all. Hmm? Is it okay? I have problem with this minus 1. Just see what do we get. I want you to check. If I write it this, will it work? For n is equal to 1, it is minus sign. For n is equal to 3, no, it won't work. So it has to be this only. Okay? Understood? Yes or no? Hmm?
Yes, ma'am.
Now I want
Yes, ma'am.
you
Yes,
to
ma'am.
solve one more question, which is simpler one, and then I'll proceed to the next concept. Write a question. If y is equal to, write a question. If y is equal to sine inverse x square, then prove that yn0 is equal to 0 when n is odd, and 2, 2 square, 4 square, 6 square, till n minus 2 square, n is even. Now in this question, the intermediate steps are not asked, but by now you must have understood you need to solve it for n first. Agreeable? Hmm? So when we solve this, you please solve. I am also solving just to save time. Y is equal to sine inverse x square. Okay. So y1 will be 2 sine inverse x into 1 upon root 1 minus x square, which is, no, not like this. I have to square it up. Now square both sides. Square both sides. So y1 square is 4 y upon 1 minus x square. I hope you can correlate. And that will give me 1 minus x square y1 square equals to 4y. Differentiating with respect to x will give me 1 minus x square into 2 y1 y2 minus 2x y1 square is equal to 4y1. Dividing throughout by 2y1 will give me 1 minus x square y2 minus x y1 is equal to 2. Just check if this is fine or not. This is our first equation and this is our second equation. Is it okay? All the calculation checked? Now differentiate n times using Leibniz. What will you get? This will give us 1 minus x square y n plus 2. Now I am writing it in one step and I am assuming that you can understand this. Just check if it is okay with you or not. Had I missed something? No, I'll get one more step. Plus, sorry, the second term I have not differentiated. Minus x y n plus 1 minus n y n plus minus n y n. Is this fine? That is equal to 0. I forgot to differentiate this. So sum it up and see what you are getting. Minus 2n. So if I take out minus sign, it will give me 2n plus 1x yn plus 1 and n square minus n and some minus
minus
sign.
minus x square yn.
Here it will be minus. So this will give me minus n square yn equals to 0. I want you to please check the equation. Is the equation right? Hmm? Now let us try and find the yn. Okay? This equation is understood. This is the same thing that you had been doing. So y0 will be 0. I'm not putting it again. You can check. y1 0 will also be 0. Hmm? Now when we find y2 0, y2 0 will give us 2. See, y2 0 will give us 2. Now for n greater than 2, let's see. You put x is equal to 0, you will have yn plus 2 is equal to n square yn. I want you to check this if it is right or not. Hmm? Is this fine?
Yes, sir.
Yes, ma'am.
Okay. So next value that we have to find is y30, and that will be, you will put n is equal to 1, so 1 square y10, and that is 0. Now y40 is 2 square y20, that is again 2 into 2 square, right? Because y20 is 2. Now y50 is 3 square y30, and y30 is 0. y60 is 4 square y40, and that is 2 into 2 square into 4 square. So by now you must have realized how it is proceeding. All odd values are giving you 0, and all even values are giving you a sequence of this type. So if I have to write the value of yn, how will we write? Yn0 is 0 when n is odd, and it is 2 into 2 square into 4 square, next is 6 square when n is even. What will be the last value? If you have 6, it is ending at 4. If you have 4, it is ending at 2. So last value will be
-2.
n minus 2. This is n minus 2 square. I hope you are comfortable in this kind of question. No problem, no issues. Ask if you have any doubt, otherwise I have to start next thing. Nobody has
Ma'am,
doubts. I
no
must.
doubts.
Great. If you are comfortable in this kind of question, believe me, you should be able to get 8 to 10 marks in one question in finals. You should definitely get one such question. All right. Just maintain the pace and focus on the questions, because generally students do mistakes in calculation, so that you have to avoid. Otherwise, these questions are very easy ones. Just 6 formula you have to remember, which I had given in the beginning, and rest all are easy. Okay. So let's try the next part of the portion. Next is the expansion of a series. Just a minute. Okay. So the next thing that I have to explain is expansion of series. Expansion of function of one variable. Okay. Here we will study for one variable, and once we are finishing the partial derivatives, we will be doing it for more than one variable, means two variable or even three variables sometimes. So I want you to read this expansion. The first series is known as Taylor series. What you do, you expand the function around that value and try to write the function from the neighborhood point of view. So if higher order derivatives of fx at the point A exists, then Taylor series of the function about the point A, that is in the interval this, is defined like this. Okay. There are two things you need to understand in this. The first thing is that the function should have all higher order derivatives. Okay. And the second thing is you are finding the value in the neighborhood of a point. Okay. So A should be specified to you, and all higher order derivatives should exist. Then you can find any point x in this interval by this expansion. This is the way Taylor series is defined. What is the beauty of this Taylor series? The beauty of this Taylor series is you get the function in polynomial form. Are you realizing? This x minus a square, x minus a cube, x minus, they all are the terms of a polynomial, and f dash a, f double dash a, f triple dash a, they have some fixed values, right? So however the complicated function you have, if you are able to express it in polynomial form, then executing this function for different uses becomes easy. As you are aware that the polynomial functions are the most smooth and useful function in entire algebra. Is that okay? Hmm? So what is the
Yes,
motive
ma'am.
of Taylor series? To get the function in polynomial form. And what is the requirement for a Taylor series? That the function should have higher order derivatives in the neighborhood of the point at which you are seeking expansion. Now the next series is Maclaurin series. And how do you get Maclaurin series? The moment you put a equals to 0, then the series that is generated is known as Maclaurin series. So you can assume that Maclaurin series is a special case of Taylor series where a is equal to 0. Is it fine? Now please note down the series and then we will solve some questions based on it. Note down the series. Noted? Now I am writing the series and some direct implication of the expansion. First I am focusing on Taylor's. And what we do, we write the function f(x) is equal to the function is, tell me how you write. Just now you have written, right?
fa plus
Fa, yes, plus
x minus a
hmm,
into
f
first
dash a,
derivative of
hmm,
plus x minus a square, but divided
f
by
double dash a divided by factorial 2
2.
plus x minus a cube upon factorial 3 f triple dash a, and so on, right? Now there are some direct implications of it. If in place of x I write x plus h, hmm? If in place of x I write fx plus h, then what can we assume it as? You can take h as, just check, here you are expanding fx. If in place of x you have x plus h, then how will it change? In place of a, this x minus a, you will write h. Okay, so this can be written as fx plus h f dash x. I want you to note this down also. X square upon factorial 2 f double dash x plus h cube upon factorial 3 f triple dash x, and so on. This is also a way of writing fx.
Ma'am, can you repeat why we put h instead of x minus a?
See, this is Taylor's theorem, this part. Okay. Now when you make this h as x minus a, You just write this is the theorem and this is a special case.
Okay, ma'am.
Okay, why? How we get this special case? Here what you do, if you write x as a plus h or a plus x minus a, first you write, I'll tell you how we get it. First you write this expansion, then I'll tell you what has been done.
Okay, ma'am.
Done.
Yes, ma'am.
Now focus on this. Okay, now this is your expansion. Suppose in place of x minus a, you write h. Then what will you get here? You will get x as a plus h. Will you? If you x minus a, you write as h, then this place will be f of a plus h, right?
Yes,
Yes,
ma'am.
ma'am.
And then this will change into hf dash a, hf double, h square f double dash a, h cube, and so on. So these are some direct changes and direct manipulations or direct subsidiary results that we are getting. Okay. So whether we expand fx like this, or we expand fx plus h like this, or we expand f of a plus h as fa plus hf dash a plus h square by factorial 2f double dash a. So these are three different expansions of Taylor's. Okay. The most easy way to remember is this part. Either you remember this or you remember f of a plus h. I'm changing it as f of a plus h, this part. And then you can calculate any kind of expansion which is as in Taylor form. When I'm saying any type of expansion, then you have to understand what does it mean. Like there is a question. Let us start with the first question. The first question is, expand log 1 plus x, expand log 1 plus x in powers of x. Okay, expand log 1 plus x in powers of x. That means what should we take as h? That is important. If you check this, these values are constant values, right? And if you check this, you are getting the expansion in powers of h. So if we are interested in finding the powers of x, that means we treat this x as h and proceed and use this formula. Is this okay or not? If I mark this as formula 1 and mark this as formula 2, which formula will help us? Formula 2 will help us by taking this as h. Now see the expansion. What is our fx or what is our fx plus h? Our fx plus h is log 1 plus x. Okay, so keep that thing in mind and expand. Our a is 1 and h is x. Is this acceptable or you have any problem in understanding this?
Ma'am, I don't see the difference between the first and the second formula.
No difference, beta. No difference. Just two ways of writing it. It's same. Here, when you are expecting the answer in x, you use this. When you are expecting the answer in some other powers, you do this. That's all. Here the value is mentioned. Here the value is not mentioned. Any x is there. Are you getting the point? In this
Yes,
case, you
ma'am.
have you have one as the mentioned value and h as x. So first of all, we will try and find out the different values at 0. Okay. Now the first value, in this case, the first value f0 is log 1 plus 0, and that will, when you are saying as powers of x, that means your a is becoming 0. Just remember this, log 1 and that is 0. Okay. Now f dash 0, first you find f dash. So what is f dash x? 1 upon 1 plus x. So f dash 0 is 1 upon 1 plus 0, that is 1. F double dash 0 is minus 1 upon 1 plus x squared, so minus 1. F triple dash 0 is equal to, what will be the triple dash 0? Plus 2 upon 1 plus x cube, right? It will be 2 upon 1 plus x cube, no? So that is 2, and so on. So let's see how we write the expansion. Just a minute. We are using the formula f of x is equal to f0 plus x f dash 0 plus x square by factorial to f double dash 0, and so on. What has been done here? This is 0 plus x type. Okay. And what is our x that we have taken? That is 1 plus x. So the output will be f0, that was 0, plus x into f dash 0, that is 1, minus x square upon factorial upon 2 plus x cube upon 3, and so on. And this is your logarithmic expansion. Similarly, I expect you to try for ex and then try for ex cos x. And you are doing it about 0. That means you are finding its Maclaurin series. Okay. I'm repeating it because somehow I'm not getting any response. That means you are not able to follow. I'm repeating it. Just check what is being done. Let me see the other one. It must be, no, it's not there. Okay. That question is not there, but some other question is there. So from there you can understand. Find Maclaurin series for sine square x by using the series of cos 2x. Now you got fx, you got f dash x, and so on. And then you have written using the formula, see, cos 2x is this. Use this formula and see what you are writing. This is the direct, in this no formula is being used, you are doing it directly. See, are you following it or not? I don't think you are following. Hmm? Just check the function again. See what you have.
I understood that example, but this example is not clear.
Okay, fine. I want you to just go through this one more time. How Maclaurin is used. Maclaurin is fx is equal to this. Okay. What you are doing? You are taking it about 0. So when you put a as 0, you will get fx is equal to f0 plus x f dash 0 plus x square upon factorial 2 f double dash 0 and so on. When do we use this? When we have to expand the function in terms of x. Like in previous question, it was asked that expand log 1 plus x in the powers of x. So we took fx as log 1 plus x and we expanded. I hope now that example you are able to correlate. Hmm? The
Yes,
example that
ma'am.
I took. Now in the next question, it is asked find Maclaurin series for sine square x by using the series of cos 2x. Okay. Now you know that there is a connection between cos 2x and sine square x. And what is that connection? The connection is sine square x is 1 minus cos 2x by 2. Now what has been done, how the cos 2x series is being
Ma'am,
calculated.
time is attendance. Next class is about to start.
No problem. We still have 1 minute. Here, if this expansion is not calculated thoroughly, it is expected of you to calculate it using the same concept as we have done in the previous one. Okay. So, I'm leaving this for you, and in the next class, I will continue from here if it is not clear to you. Just 1 minute. Please start marking your attendance on chat box, meeting chat box. By the time I open this Amazon, this particular PPT is already uploaded on LMS. You can check it from there and read it and match your answers. Now respond to your attendance. Someone has very noisy surrounding.